Hello everyone, my name is Capacitance. I'm an electrical and electronics engineering student at Bilkent University. This is my second semester. I will introduce my Physics 102 experiment project to you. Aim of my experiment was to calculate the equivalent capacitances with half-life time measurements. We will analyze the RC circuits with different number of capacitors, either connected in series or parallel. We will use the half-life time formula to calculate the equivalent capacitances. We will obtain the half-life time values by charging and discharging the capacitors. The charging process of a capacitor can be shown with the formula here. After charging them and getting them to initial voltage, we will disconnect the terminals of the capacitor and they will undergo a discharging process. While they are discharging, the voltage across the plates of the capacitor will drop. When this value drops to half of its initial value, I will stop the chronometer here, and these values will be recorded as experimental half-life time values into table 1 and table 2. Now let me show you my equipment here. This is my DC power source. This is my chronometer. This is my multimeter. These are my crocodile cables, and here we have a resistor, 220k ohms, and we have identical capacitors of 100 microfarads here. Now let's demonstrate for two series connected in series here. I will start the chronometer and disconnect the terminals. When this value drops to half of it, I will stop the chronometer, and this will be our experimental half-life time. Yes, we obtained our experimental half-life time for two capacitors in series, and this will be repeated for 3 and 4 capacitors in series and in parallel. For parallel case, we will record the values in the table 1, and for series case, we will record them in the table 2. With these values, we will calculate the equivalent capacitances. Using these equivalent capacitance values, we will draw a natural logarithm of capacitance versus natural logarithm of number of capacitors graph. In this graph, we expect the slope of 1 in the parallel case, and we expect the slope of -1 in the series case, since the capacitance decreases with the increasing number of capacitors in series case and the converse case for the parallel. In this experiment, we have two types of errors. One of them is random errors. Random errors are caused by the environmental factors such as heat and temperature and other environmental factors. They can alter the results randomly. Secondly, we have systematic errors, which are stemming from the sensitivity, calibrability of equipment and human mistakes. Since we cannot measure really small amount of times, it can alter the results to a great extent.